Everybody, just checking in with you for our AP Stat Chapter 9 review. Going to be going through the free response questions from our practice test. And now when we look at this first question here, question 11, you've already read the problem, so I'm just going to get to the important parts here. The company needs to sell it to more than 20% of its customers. Well, first of all, we see 20%, therefore this is a proportion problem. Therefore, there's going to be a one sample Z test for proportions. The fact that it says more than here tells us something about our alternative hypothesis. We have a random sample of 60, and it says they find that 16 would be willing to pay. Well, that's going to give us some information about our p-hat. Our p-hat is going to be 16 out of 60. All right, so the first question says, do the sample provide good evidence? That's the same thing as saying convincing evidence, significant evidence, etc. That tells us we're going to be doing a significance test. Obviously, it also gives us even that further information right here, telling us to use 5% significance level. So when we look at A, we know we need state. What is the parameter that we are asked to find information about? The parameter is P, the true proportion of the company's customers willing to purchase the upgrade. Our null hypothesis is going to be that P equals 0.2, because HO is always that an equals value there, and it's proportion, so that's why it's P, never P hat. HA is that P, we want more than 20%, so P is greater than 0.2. And even though they stated the alpha, you should always include it in your state step as well. As far as the plan, like I said before, this is a one sample Z test for proportions. As far as our conditions, we are told that it's an SRS. Slide that up there for you, sorry about that. Independence, well, our sample size was 60, so we must assume at least 600 customers in order for the independence condition to be met. For the normality condition, since this is a proportion problem, we're going to check n times p and n times 1 minus p. Now when we look at this here, notice it's p, not p hat. So my sample is 60, but I'm going to multiply that by 0.2 because that's the claimed proportion. And when we do that, we get 12. And when we do 60 times 1 minus 0.2, or times 0.8, we get 48. We know that both of these are greater than or equal to 10, therefore approximately normal. Don't lose points because you forget to state what that check tells us there. All right. Then we move on to our do step. In our do step, we're going to calculate the test statistic Z, which the formula is p hat minus p divided by the square root of p times 1 minus p over n. Because this is a significance test, we use the p to find the standard deviation rather than the p hat that we would use in the confidence interval. And when we plug in, we have 16 over 60. That's the p hat that we found and that they were given to us in the original problem. The claimed p is 0.2, divided by 0.2 times 0.8 over 60, just filling in there, and we get a value of about 1.291. Now when we think about this in a normal curve scenario, we know 0 is in the middle, 1.21 is kind of over here, and now we have to say, okay, this value we're trying to find greater than, so we know we're going to be shading to the right. Now, when we look at this, to get the p-value, slide that up again, to get the p-value, we know we're going to use normal CDF. We're not going, and we use normal CDF because it's the Z test that we're doing, as opposed to if we were doing a T test, we'd be using TCDF. Sorry, There we go. Don't multiply by 2 because it's a one-sided test. So we're just going to say, okay, 1.291, that's our lower. Up to 999, that's our upper. And because this is a z value that we're using, the mean is 0 and the standard deviation is 1. And when we do that, we get a value of 0.0984. Now, we always want to compare that p-value to the alpha. So we say, since, in this case, p is greater than alpha, because p is 0.09, and the alpha, as we stated above, is 0.05. P is greater than alpha. We fail to reject HO. And since we fail to reject HO, therefore, we do not have good evidence that I should say more than 20% of the customers will purchase the upgrade. Okay, so again, oh man, I need to do it again. There we go. So again, the goal was to see if more than 20% will purchase the upgrade. Because our p-value is greater than 0.05, we failed to reject that. Therefore, we do not have convincing evidence. All right. The other two questions, it says in B, which would be a more serious mistake, a type 1 or type 2 error? Well, type 1 error is rejecting HO when HO is true. So rejecting HO, in this case, what we would say is that we think that the proportion, if I went back up here to my HOHA, if I reject HO, then I think that the proportion is greater than 0.2, which means that the company is going to go ahead with this upgrade. And they're going to go ahead with the upgrade, and they're not going to have enough people to support it. So therefore, the company's going to lose money. But if I had a type 2 error, that would be a situation where I don't think more than 20% will buy it, so I'm not going to do the upgrade. Now, could that lead to a loss of revenue? A little bit, but a type 1 error, I would argue, is more serious here, because they're going to produce an upgrade and not be able to sell it to enough people to make money. So I would argue a type 1 error is more serious in this case. You know, if you wanted to make an argument on the other side, that's certainly something that you could attempt to do and still attempt to get full credit. The other part to this question, it says to describe 2 ways to increase the power. Well, we know, we've talked about this for many days now. 4 ways we could increase the sample size. We could increase alpha, the probability of a type 1 error. We could decrease the standard deviation. Or we could choose an HA further from the claimed HO. That's another way of saying we could increase the effect size. All right, that's it for this first example, and I'll have another video for the other 2 examples in a little bit.